Hello dear students, welcome to the second part of this lecture. In part number 1, we talked about the selection sort algorithm, theoretical aspect, background, how the selection sort technique actually works to sort out data. If you recap the concept that we have learned in the first part, we emphasize on the things that selection sort algorithm is actually a comparison based sorting algorithm, because the main activity of the selection sort algorithm, like the bubble sort algorithm, is the comparison between two elements and swap them out if they are out of order. Then we saw different journal examples and we applied the selection sort algorithm to sort out the data. Different flavors of the selection sort algorithm are available. For example, two of them we have already seen. If you want to select or search the smallest value, then you have to sweep the smallest value with the element at the first location and then at the second and third and so on. However, if you want to implement the selection sort algorithm in another way, in another flavor, that could be searching for the largest value, then in that case you have to swap the largest element with the element at the last location and then with the element at the second last location and moving on. So now it's time to see the dry run of the algorithm applying the pseudocode over a list of unsorted data. So what you see here is the actual selection sort algorithm. Let me tell you one more thing, that as different flavors of the selection sort algorithm are available, different pseudocodes are also available. Maybe on the internet or in books, you may be able to find other versions of the selection sort algorithm, but it doesn't mean that one is wrong, the other is correct. All of them are correct, but there are different ways of how you can actually implement the selection sort algorithm. So I found this algorithm straightforward, classical algorithm, and easy to follow. That is why I have selected it for this lecture. Okay, to perform the dry run, I actually need a board and a marker. So as we are taking our classes virtually online, it's a bit complicated for me to actually draw the things, because I do not have the virtual the digital pad available, the drawing pad, which make it easier for the resource person, for the teacher, to draw things or to work with mathematical equations or with calculations. However, I will be using my mouse and live board for dry run. You need to be patient. Sometime things would be ugly because it's not the physical environment, but I hope so. You will bother me. You will not bother me, or you will have to show some patience because things are going to be slower, because it's difficult to write with the mouse cursor. Okay, but I will try my best. So here is the pseudocode, the algorithm for the selection sort. It contains 7 steps. In step number 1, we are using a loop. In this case, it is going to be the for loop. The variable for the for loop is I. The initial value is 1. The final value is n minus 1. And we have to repeat step number 2 to step number 6 for each value of I. You can say that in step number 1, we are actually controlling the number of passes over the data. So if you remember, we require n minus 1 passes over the data. Why? Because the last element is already in sorted form in case of the selection sort algorithm, or if an unsorted array has one value, then it is also in sorted form or already in sorted form. So that is why we need n minus 1 here. Second thing is that in this algorithm, we are actually interested in finding the smallest value in the given list. So I am using another variable, and that variable is called small. and its initial value is I. So if the value of I is 1, the value of small will be 1. And that is, we have to start from the first element. We need to imagine that the value stored at the first location is actually the smallest, and then we have to compare it with the rest of the elements. So first we need to compare the element at the first location with the element at the second location. So that is why I use another loop, and the variable here is j, and the value of j is I plus 1. There is 1 ahead of I. So if the value of I is 1, the value of j will be 2. And as we are starting it from 2, then we have to move till the end of the array. So we have to mention here n, not n minus 1. And finally, we have to repeat the inner loop as long as we are in search for the small. For example, we have supposed that the smallest is at location 1. What if the value at location 2 is smaller than the value at the location 1? So in that case, we have to move the pointer small to the next location, that is j. For example, if the value at location 2 is smaller than the value at location 1, that small will now point to the location 2 instead of 1. So at the end of this phase, we will be able to find the smallest value. And then in step number 6, actually the swap will happen here. But the swap is required only if the value of the small variable change during the execution of this code. If that is not the case, then there is no need to swap. Means if the smallest value is already in the proper position, then there is no need to swap. However, if that is not the case, then we need to swap the elements. And for swapping, we need another variable, and that variable is commonly referred by a temp. So we declare a third variable, we assign the value of one variable to it, and then we actually assign the value of the other variable to the small, and then the value contained in the temp is assigned to this variable. We will see it in the dry run. The things will become more clear when we perform the dry run, but let me repeat the concept what's happening in the selections or pseudocode. So first thing is that actually we are using two loops. One loop for number of passes, the second loop for comparison purposes. This loop is called the outer loop, this loop is called the inner loop. For one value of the outer loop, the inner loop will execute it again and again. Next thing, total number of passes is n minus 1, because if you have, for example, the value of n is 5, then total of 4 passes are required to sort out the data. So that is why starting from 1, the final value of I is going to be n minus 1. So if you have 4 elements, then the loop will work for 1, 2, and 3. 3 times. Total number of passes are going to be 3. Second thing, we need to consider that the value stored at the first location is actually the smallest value. That is only a supposition. To start the algorithm, we consider that the value stored at the first location is the smallest. However, it could be the case that the value stored at the second position or at the third position or at the fourth position and so on, it could be smaller than the value stored at the first location. For that purpose, we need to compare the smallest value with each and every element with the help of this inner loop. Once we find the smallest value, we have to take a decision whether we require the swap or not. So if you remember, if the smallest value is already at the appropriate location, then there is no need for swap. However, if that is not the case, then we have to swap the element with the element at the first location. For that, we need a third variable, and I refer to that variable with the help of temp. So we need to store the value in the temp variable for the purpose of swapping. And then finally, we will execute this, we will exit this algorithm. So let us see the dry run. Okay guys, the hardest part has arrived. Let us see. First, I need to draw an array. Okay, here we go. Oh my god. 1, 2, 3, 4. Make it 5 elements. Let us give this array a name. So the name of this array is A. Index is starting from 1. I think I am doing it very well. Oops. It's really interesting, but a bit difficult. Okay, so the values are in unsorted form. The first value is 40, 30, 5, 20, and 10. Okay, so we have a problem now. The data is in unsorted form, and we need to sort it out with the help of selection sort algorithm. So in this particular case, the value of n, total number of elements in the array or in the list, is 5, right? Okay, so I need to switch to the algorithm. Step number 1 is for loop, and the variable is I, and the value is 1 to n minus 1. So step number 1, for loop, initial value of I is equal to 1, and I is less than or equal to n minus 1. So the value of n is 5. So 5 minus 1 is actually 4. So this is our first step. This is actually for loop. I do not need to mention for here because it's already there in the pseudocode. But okay, no problem. So this is step number 1. Now step number 2. Take a variable small and assign it the value I. Step number 2. Another variable small, and its initial value is I. So I will not write I, you know the value of I is 1, just to make thing a bit easier for writing. This is step number 2. In step number 3, again we have a loop, but this time the loop is started from I plus 1 up to n. So step number 3, actually the variable is j. The value of j is 2, that is I plus 1. Oops. The value of j is I plus 1. It's 2. But let me make it I plus 1, so that later on we do not, just to avoid confusion in the coming steps. That is j is equal to, the value of I is actually 1. You see, I is equal to 1, so 1 plus 1 is equal to 2. And the final value of j could be j is less than or equal to n. So the value of n is 5. That's it. Okay, guys. What else? We have assigned values to the variables, and now let us start giving it a try. First, step number 1. The value of I is 1. So check the condition. 1 is less than or equal to 4. Condition here is true. If the condition is true, what we have to do, if this condition is true, then you have to execute step 2 to step 6. So step 2, step 3, 4, 5, 6 will come now. Okay, assign small the value of I. So the value of I is 1. So already done. So small now has 1. Assign value to j. The value of j is 2. Check condition. 2 is less than or equal to 5. Okay, this condition is also true. So once the condition is true here, what you need to do, if this condition is true, you have to execute step number 4 and step number 5. Now this is part of the inner loop. So step number 4. Step number 4 is the comparison a of j with a of small. I will try to put the values a of j. What is the value of j? The value of j is 2. So a of 2 is less than a of small, and the current value of small is 1. Check this condition. If this condition is true, then we have to, if this condition is true, then we have to assign small the value of j. So let us put values. A of 2, this is a, this is 2. The value here is 30. 30 is less than a of 1. This is a, this is 1. A of 1 is 40. Now check. 30 is less than 40. Okay, yes, condition is true. 30 is less than 40. Then you have to move to step number 5. And in step number 5 is actually you have to assign a new value to the small, that is j. So small is equal to j. Small is equal to j, and the value of j is 2. So you see, previously small was referring to the first location, but now after comparison we came to know that the value stored at the second location is actually the smallest value in the two. So now small actually refer to this element. Now we have the smallest element at the second location, right? Okay guys, now we will not go forward to step number 6 because we have an inner loop here. So you have to go back to this inner loop in step number 3, right? Here you have to increment the value of j by 1. I think it would be better to move to the next page, but the problem is that if I move to the next page, then I have to write all the things again. What to do, guys? I think it would be better to make let us give a try. Wow, it has the option of copy. Great. Copy. Mm, mm, mm. Oops, 4 pages. I'm not able to see the copy. Wait, I will resolve the issue. Mm, mm. It's working very slow. Things are happening, but slowly. I need only few more pages. Yeah, I get a new page. Problem is it's processing very slowly. Okay, I will pause the video for a while. Okay, so finally I was able to make a copy of this page. Let's move to the second round. We have to go back to the inner loop, and in the inner loop we have to increment the value of j by 1. So the previous value of j was 2. After incrementation, the new value of j will be 3. I need to change the size. Got it. So the new value of j is 3. Check the condition. Now the value of j is 3. So we will get 3 here. 3 is less than or equal to 5. Yes, condition is true. Once the condition is true, we have to execute step number 4 and step number 5. Now in step number 4, here we have, if you see the algorithm a of j and a of small. So the value of j is 3. So we have to put here 3, and the value of small is now, the value of small is 2 now. Yes. So by putting these values, we have the value of j3 and the value of small 2, because now the smallest refer to this 2 now. Okay, compare them. A of 3, this is a, this is 3. The value here is 5. We have 5 now, and we have 30 here. So 5 is less than a of 2, which is 30. So check the condition. Whether 5 is less than 30? Yes, condition is true. If this condition is true, then we have to assign the value of j to small variable. So the value of j now is 3. So it means that now the smallest value in the list is at location number 3. Also make change here. Now our small actually refer to this location. You see, we are actually trying to find the smallest value in the list. Until now, the smallest value in these 3 values is at location 3, that is 5. Again, we have inner loop. Go back to step number 3. Increment the value of j by 1. The previous value of j was 3. The new value of j will be now 4. Check the condition. 4 is less than or equal to 5. Yes, condition is true. It means we have to execute step number 4 and step number 5. In step number 4, now we have to change the values here as well. Okay, so now here we have to write the value of j, that is 4. You can see from here, and the value of small, that is actually 3. The current value of small is 3. Okay, now check the condition. A of 4, this is a, this is 4. The value here is 20. So a of 4 is less than a of 3. This is a, this is 3. The value here is actually 5. So we will put 5 here. Okay guys, so 20 is less than 3. Do you think? No. So now we have the condition false here because 20 is not less than 5. If that is the case, we will not execute this statement. You see, it will happen only if this condition is true. But now the condition is false, then we do not have to change the value of small. Go back to step number 3 again. Increment the value of j by 1. The previous value of j was 4. Now the new value of j after incrementation will be 5. Check the condition. 5 is less than or equal to 5. Yes, it's not less than 5, but is it equal to 5? Once the condition is true, you have to go to step number 4 and if possibly step number 5. So go to step number 4. Here we have to put the value of j. So the new value of j is 5 now. Put 5 here. A of 5 is less than a of small. Again, the value of small is same, that is 3. So compare a of 5, that is 10. The value of a of 5 is 10. Check. 10 is less than 5. No. Again, the condition is false. So this value will not be changed because this is part of the if statement. If this condition is true, execute this statement. If this condition is not true, go back to step number 3. Now here you have to change or increment the value of j by 1. Inner loop, it will execute as long as we have the condition true. So now the value of j is 6. Again here we will get 6 here. Okay, so 6 is less than 5. No. 6 is equal to 5. No. So both the condition are false, which means we will not execute step number 4 and we will not execute step number 5. These statements will be executed only if this condition is true. But now the conditions are false. So this statement will not be executed. Okay, now we are still here. For one value of the outer loop, there is 1, we execute this statement, but until step 5. Now we have to execute step number 6. And step number 6 is to sweep the value at the first location with the value that is the smallest in the list. So let us go to step number 6 now. Let me try to add a new page. Problem is that I'm not able to shift to the new page. I don't know why. And the solution is that I will make another copy. Yeah, copy board. Okay, open, and I will make changes here. Okay, so let's move to step number 6. I will erase here. Much longer. Erase. Where is the CR? Please come forward and erase the board for me. Done. Thank you, CR. Okay, step number 6. Wish I have to make changes to here as well. Pronto. It's having fun to work with Lifeboat. So step number 6. What's happening in step number 6? First, we have to check whether the small variable value has changed during the execution or not. So check the condition. The value of small is not equal to I. This is for not, this symbol. So put the value of small. The value of small was 3, if you remember. And the value of I is still 1. You see here, the value of I is 1. So 3 is not equal to 1, which means true. The condition is true. Yes, 3 is not equal to 1. So if this condition is true, you have to sweep the elements. And that is going to happen in 3 steps. Remember, we need a third variable, temp, and temp is, wow, it's better to write like this. So what do we need to assign to temp? A of small. This is A, the value of small is 3, so this is 3, and the value here is 5. Assign 5 to temp. Okay, got it. Step B, A of small is equal to A of I, which means assign A of I to A of small. So this is A, this is 3, this is A of 3, A of small, it is 5. Assign this A of 3, what value we need to assign to A of 3? We need to assign A of 3 the value of A of I. This is A, this is I. The value of I is 1, so A of 1 is 40. Assign this 40 to A of 3. Let assign it. This is A of 3. We need to assign 40 here. Okay, the previous value has been lost, but don't worry, because we have saved the value in temp variable. Okay guys, now step number C. Now assign the temp to A of I. The temp is 5. Assign this 5 to A of I. This is A and the I is 1. This is 1. So assign A of 1 5. We have to assign 5 to A of 1. Okay, we have made it. So what you see, we have actually swapped the two elements, or you can say that now the smallest value in the list was found out and then it was swapped, or it was bring to the correct location. There is location number 1. And you can also see that the algorithm has divided the given list into two subparts. One of the portion is already in sorted form. The remaining of the elements are not in sorted form yet. But then you have to repeat the same process. Let me go one step forward. This was actually step number 6. Now you have to go back to step number 1 and here you have to increment the value of I. The previous value of I was 1, the new value of I is 2. So check the condition here. 2 is less than or equal to 4. Yes, condition is true. Okay, then you have to move to step number 2. Now the value of small is I and the value of I is 2. So small is equal to 2. You have to start from here. Now your first element is 30. And then you have to repeat the next, the same process for the remaining of the list. So this was how selection sort pseudocode actually work. We saw the dry run, although it was a bit complicated for me to write down the things, but I really enjoyed it. What I need is a drawing pad, and I am sure I would be able to arrange one drawing pad in the coming couple of weeks. Maybe after midterm we will have a drawing pad. With the help of drawing pad, we will be able to write more quickly and more beautifully. But I'm sure it's not that much ugly it I was expecting. Okay guys, so this was about the dry run of the selection sort algorithm. And let us move to the final part of our today lecture. Let me check the time. Okay, we have time. So this was the algorithm, and now the analysis of the selection sort algorithm. Okay, wait a moment, please. Let me. Okay, so the analysis of selection sort algorithm. Analysis is done to check which algorithm is actually perform better than another algorithm. The analysis of selection sort is a straightforward process. Here, the input size is given by the number of elements, and that is represented by n, as we saw in the algorithm. And we also know that the basic operation of the selection sort algorithm is the comparison of the elements, as we saw in the pseudocode, whether a of j is less than or is less than a of small. If it is small, then we have to swap them. But the basic operation is comparison. Similarly, to simplify the things, we have different passes or different steps. You can also say different cycles. Inside every pass, we have to count the number of comparisons that we actually performed in order to carry out the analysis. So in the first pass, the total number of comparisons performed by the selection sort algorithm is actually n minus 1. You can see from here. You see the step number 1 of the pseudocode. For I is equal to 1 to n minus 1, which means total number of passes that we have to perform to sort out the data is n minus 1, one less than the total number of elements or the size of the array. So in the first pass, we have to perform n minus 1 comparison. That's it. Now in the second pass, we have to do one less comparison, which means n minus 2, because at the end of each pass, one element is sorted out, which means that element is not going to be considered for the next pass, which means one less comparison. So in the second pass, the total number of comparisons are going to be n minus 2. Similarly, in the next pass, the total number of comparisons are going to be n minus 3. And finally, in the last pass, where we have to compare the second last element with the last element, we will have to perform only one comparison, right? It means if you add all these comparisons, it is going to be like n minus 1 plus n minus 2 plus n minus 3 plus n minus 4, and then finally plus 1. And if you know this, we can actually write it into n minus 1 divided by 2. Left hand side is actually equal to right hand side. You can prove it very easily. And we saw this equation in the week number 2 when we were studying introduction to some basic concepts of the mathematics where we saw the review. So actually this equation is equal to n minus 1 divided by n into n minus 1 divided by 2. So once you have this equation, you can actually simplify it further. For example, when you open it, it is going to be like n square, n multiplied by n is n square minus n, and both divided by 2 separately. So apply the rule. We have to take only the higher order term. In this case, we have n square and n. So the highest order is n square. So consider only n square. Furthermore, you have to ignore the leading constants or the coefficients, that is 1 by 2. Ignore it as well. What's remaining is n square, or you can say big O n square. And that is the complexity, the running time analysis of the selection sort algorithm. So if you have been asked what is the running time algorithm of the selection, what is the running time of selection sort algorithm, that is n square. Now the question is whether this is for the best case, for the worst case, or for the average case. So remember, in case of selection sort algorithm, the running time is same for all the three cases, whether it is worst case, whether it is best case, or whether it is average case, you will get the same n square. So in summary, we have the worst case analysis of selection sort as n square, the best case as n square, and the average case as n square as well. So the best case, the worst case, and the average case of the selection sort algorithm are the same. It's part of an MCQ. Sorry, you may be asked whether in the selection sort, the running time is same for all the three cases, whether it is true or false. So it is true. This means that the behavior of the selection sort algorithm does not depend on the initial organization of the data. This is the conclusion, and this is very important. Whether the data is already in sorted form, whether the data is in reverse order, or whether the data is half sorted, doesn't matter. The running time is going to be the same. And we saw it in the example where I give an indication that, see, the data has already been sorted, but the algorithm is still processing, still working, going further to sort out the data, try to find the minimum value, right? So that is the case. Whether the data is in sorted form or in unsorted form, the behavior of the selection sort algorithm does not depend on the organization of the data. And that is why the time complexity of this algorithm is the same in all the cases. Because at every step you have to find the minimum or the maximum value and then put it in the right place. And as we know that the minimum or the maximum element is not known until we reaches the end of the array. So that is why the time complexity of this algorithm is same for all the cases. You can find the running time of selection sort algorithm by other methods as well, but they are complicated. Another simple method is that just by looking at the number of loops, as there are 2 loops inside the selection sort algorithm, so it means that n multiplied by n, which will give you n square. So that is also a possible analysis of the selection sort algorithm, and a simplest one as well. But this one, I found it the most simplest way to analyze the selection sort algorithm by looking at the basic operation of the algorithm, there is the comparison, and then looking how much time we are actually performing the comparison at each cycle or at each pass. So for example, at every pass we are actually performing one less comparison and then adding them. You will get an equation, there is n into n minus 1 divided by 2. Multiply them, taking the taking only the highest term and ignoring the leading constant, you will get n square. And that is same for the worst case, for the best case, and for the average case analysis. Thank you so much. This was all about the selection sort algorithm, its pseudocode, and its running time in worst case, best case, and average case, or the complexity of the algorithm. I hope you will get some ideas from this lecture about the selection sort algorithm. We started our journey with the basic introduction of the selection sort algorithm. In the introduction, we saw that it is also a comparison-based sorting algorithm, which is inefficient on large data because the running time is n squared, so it's not what a recommended algorithm is for large data. And like bubble sort it is actually a simple sorting algorithm, and the technique is also very simple. You find the minimum or maximum value and then swap the value with the first position or with the last position, and then comparing the elements with the rest of the elements. Logically, the array is divided, or the given list is divided into two parts. First sublist is in the sorted form, while the second sublist is in the unsorted form. And then gradually we are increasing the numbers of items in the sorted form, and at the end of the algorithm, all the elements come to the sub array which is in the sorted form, and the unsorted sublist become empty. And then we saw some general examples how the algorithm works. We also saw technical details of the pseudocode. We apply it, or we give the algorithm a dry run, and finally we saw the running time of the selection sort algorithm. So it was all about today's lecture. Thank you so much, and thank you for your time. Goodbye.